You're driving around a city 15 to 20 miles a day. Battery electric vehicles make a great deal of sense. If you own a commercial fleet of trucks, do you want to pull that cab off the road to charge it, or do you want to just fill it up with a hydrogen station and be automatically back on the road? That's what I want to do.
This is Energy Cast, and I'm Jay Downhauer. Today we're talking about hydrogen fuel cells and how fleets of vehicles could help pave the way for the hydrogen economy. You've probably been hearing about hydrogen fuel cells a long time. Technology is over 200 years old. The first hydrogen fuel cell vehicle was built 60 years ago this year, and efforts have been underway to build commercial fuel cell vehicles ever since. So what's taken so long? It seemed like these cars were on their way about 10 years ago. You may remember this tagline Chevy was using back when the Chevy Volt made its debut.
Chevy, from gas-friendly to gas-free. That's an American revolution.
Yeah, along with some trendy logos for ethanol, hybrid, electric, and yes, fuel cell there at the end. They produced a fuel cell Equinox between 07 and 09, but nothing since. So far, there's only 3 fuel cell vehicles on the market, only in California, produced by Hyundai, Honda, and Toyota. My guest says he has a solution to get things moving. Start with fleets. These vehicles are usually centrally located, and as he points out, the infrastructure to support 150 vehicles or 15 isn't much different. They also focus a lot of their business on forklifts, which normally run on either electricity or propane. He says he can retrofit older vehicles or modify new ones. Fleet size leads to efficiency, and some of his customers include Cisco, BMW, and Walmart. So just how big is Walmart? I'll let this skit from SNL with Amy Poehler and Jennifer Gardner give you an idea.
Hi, welcome to Walmart. Hi, you are now officially in Walmart. Oh, thank you. Can you tell me where I might be able to find bath rugs with patriotic baby ducks on them?
Oh, bath rugs with patriotic baby ducks is in aisle 6,000. And here, you're going to need this poncho, because I think it's rainy season in that part of Walmart.
And they might not speak English over there because there are 3 indigenous languages to this Walmart.
I love that skit. My guest and I also talk a lot about energy storage on this show, and he says hydrogen could be a great storage solution, although not the way you might think. Rather than fuel cells, he believes renewable energy, which can be intermittent and frustratingly abundant when it's not needed, could be tapped to make hydrogen during off-peak hours. In addition to fuel cells, hydrogen could one day provide widespread carbon-free energy for fleets of hundreds or a family of one. My guest this week is Andy Marsh, President and CEO of Plug Power, a hydrogen fuel cell company based in Albany, New York. Plug was founded in 1997, and Andy came on board as their head in 2008. Plug Power focuses on both hydrogen supply, with a product to dispense the fuel like you'd see at a gas station, as well as a number of fuel cells in different shapes and sizes. They can range from one small enough to power a drone to the FedEx delivery truck driving through your neighborhood. I hope you enjoy my conversation with Andy Marsh.
We are here with Andy Marsh, President and CEO of Plug Power. And Andy, I feel like fuel cells, they've been a hard nut to crack on the path to adoption, but by focusing on fleets and equipment like forklifts, which you've done, it seems like you found a path to success. So what initially led you to that conclusion?
Sure, Jay. It's a pleasure to be with you today. When we thought about the industry, the biggest issue we heard over and over again was what comes first, the fuel cells or the hydrogen infrastructure. And that really kind of leads you to the conclusion that if you have large-scale fleets and you could put hydrogen infrastructure in place, fueling would be cost-effective. The infrastructure to support 10 units is often the same as the infrastructure to support 150 units. So obviously it has a significant reduction in costs per fueling. And then we liked the material handling market when we stepped back that we could make at that time a really clear value proposition. And the value proposition has a lot to do with the value proposition for fuel cell electric vehicles in general. So if you take a look back, the attributes of fast fueling, which many people are using to promote fuel cells versus batteries today, the longer range. Fuel cells can run almost 2 times as long as batteries in many applications. And in forklift applications, it was very similar. The constant power, the constant speed, the same feel as you would have with propane. And that was our insight, but it was really insights by people like Walmart and Cisco and BMW who kind of verified that there would be real value to their operations if they were using fuel cell powered vehicles instead of battery powered vehicles.
You have a fuel cell that works with a lot of different vehicles, forklifts, trucks, cars. Do you retrofit existing vehicles to work with your power packs?
Yeah, I wish I could take credit for the insight and genius in the fact that what do you want to do? Do you want to just support new vehicles in the forklift truck market? And how long would it take to change a new vehicle to be fuel cell ready? Or do you develop a product that could be easily retrofitted? We have modified forklift trucks, and I say modified, which means really taking the battery out of a forklift truck that's 14 years old and put a fuel cell in place. And that process can take about 20 to 30 minutes and the customer is ready to go. And when we look at other vehicles, though may not be as simple as it is today for forklift trucks, when you look at the FedEx truck we have on the road today that's operating here in the Albany area, the approach was to take the battery electric vehicle to eliminate most of the batteries. Some batteries remain because most systems are hybrid, and a fuel cell was put in with some software changes. But if you have a battery electric vehicle, converting it to a fuel cell powered vehicle is really not that difficult. And if you can think about that, that really opens the total available market much more rapidly for selling and positioning products.
When you retrofitted the FedEx trucks, did they already have a battery power pack in them? You pulled that out and put the fuel cell in, or did you ask for them to be delivered with the space for your fuel cells?
In that case, a vehicle was delivered without the batteries. We installed the fuel cell system and put it on the road.
There'd be a lot of battery packs just lying around if you did that. So probably saved a little bit of money that way too. Andy, hydrogen, is there a price equivalent per gallon or kilowatt that you use to compare to what it costs to power a fuel cell? How do you explain that to people?
Sure. So I think you have to look at 2 elements. For the same performance, let's take a car. In hydrogen, we usually talk in terms of kilograms. 1 kilogram of hydrogen provides as much energy to a vehicle as 2 gallons of gasoline. So the price of hydrogen, if it's 2x the price of gasoline, it's quite competitive.
You're setting up these systems in warehouses that aren't yours. I'm always concerned about user area. I came from oil fields where the joke used to be those guys could break an anvil. How do you ensure that the hydrogen is safe to use, especially when your staff presumably isn't there to administer the hydrogen being transferred to the fuel cells?
First, hydrogen, like any fuel, has to be treated in a safe manner. I never start a safety discussion without mentioning the seriousness of dealing with any fuel. In a customer premise, they will drive their forklift truck up to an inside dispenser. And the interface between that dispenser and the individual is identical to what you would see at a gas station. That's the kind of skill and training you would require. You also do a great deal of work that really limits the amount of hydrogen that you can receive out of the dispenser. And even if there's a leakage, which could be much lower than any level of hydrogen that could cause problem, the system would shut down. There's lots of safety built into how the fuel is dispensed, as well as within the unit itself. But, hydrogen is in many ways safer than other fuels in certain aspects. For example, gasoline pools, hydrogen within the time I snap my fingers will be 30 feet in the air. That being said, hydrogen, its ignition energy is lower than what it would be for gasolines. And we've never had an invented a fueling incident.
Hydrogen's always been a challenge logistically. We'll kind of get into the hydrogen economy in just a second, but specifically for these warehouses and central locations, how is hydrogen brought to the central locations for your fuel cells and then stored for use? Is the hydrogen coming from a long way away? How readily available is hydrogen when you're bringing it in bulk like this?
Hydrogen today that we use is primarily in the liquid state when it's delivered. There are in the United States and Canada 7 large liquid plants, and 3 additional liquid plants are coming online. And by storing the hydrogen in liquid form, you get the advantage of density, which is about 6 to 7 times better than gaseous form, which means you can transport much longer ranges cost effectively. We deliver hydrogen to the site in liquid form and transform it into gaseous hydrogen.
In my limited knowledge about how hydrogen is made, isn't most of it made from natural gas reforming? Are there other methods that you like? It seems like you know a lot about hydrogen.
You're absolutely right. Most commercial hydrogen today actually comes from natural gas. A high percentage of the hydrogen that Plug uses comes from chloralkali waste streams and often converted into liquid form using hydroelectric power. We also believe that as most people are very geared towards the development of green hydrogen, and the best methodology for creating green hydrogen is to use electrolysis. And electrolysis is becoming really interesting as the grid becomes more renewable. And I know this is an area you know a lot about, Jay. And with more wind and solar coming online, and often you have times where you have too much wind and solar, and you can turn it into hydrogen fuel with a value that could be 10 times more. That's a pretty good value prop. By 2030, I suspect about 50% of the hydrogen used as fuel will come from traditional green renewable sources, and ultimately maybe nuclear power plants.
You know, you mentioned natural gas reforming, which is what they make most of the hydrogen from, but just going to put my skeptic hat on here. You know what I'm going to ask. Why would you want to take natural gas and convert it to hydrogen when you could just use the natural gas? What's the answer to that?
To me, it really comes down to pure electric vehicles, and that's really an interesting question. But I'm a power engineer by training. I really think in terms of how one should build their powertrains. Most vehicles should be electric in the future, and not because they're greener. Electric vehicles should be lower cost than internal combustion engines because of their simplicity. They're more reliable because they're going to have fewer moving parts, and when you look at it, they're going to be more efficient. And then you lay on top of that all the electronics, especially as cars. We're in early stages of automated vehicles, but I've seen pictures of loads where the majority of the load at one time is going to come from the electronics on the car. Why would you have a natural gas engine and then have to put on top of it a whole power system to support how the powertrain really works? That just doesn't make sense, because hydrogen to fuel cells directly create that electricity.
Going back to the warehouse, I'm curious how you convince those folks to abandon conventional electricity or propane for this system. So give me your best sales pitch. How did you convince those guys to go with what you've got?
Oh, I'm going to save you money. So my biggest customer, Walmart, is quite committed to sustainability, but they're also quite committed to lower costs. That is their promise. They actually believe, and I agree with them, that sustainable solutions should be lower cost than traditional solutions. I've been to Walmart sustainability conferences, and one example they show is how you manufacture a shirt with less material. That's how Walmart thinks. And how we sell Walmart is all on productivity savings. If you're using batteries, and those batteries in a 24/7 warehouse have to run out of energy every 6 hours, and you have to remove a battery and put a new battery in, that can take up to 20-25 minutes. With a fuel cell, you can fuel a unit up in 3 minutes and be back up and operating. And for some of our products, it's under 3 minutes. So there's savings there with labor. Additionally, you have constant power and constant performance. Unlike a battery, it doesn't droop during a shift. what we've seen is that customers will see a 10% productivity savings, which either means you can move 10% more goods or you can have 10% smaller workforce. And that's what we sell today. And that's why we started down this path of material handling first, because there was a value proposition.
We're talking about the hydrogen. The last time I looked at a hydrogen economy, I believe I was told we'd need to add a totally new pipeline infrastructure. Is it that complex, or could we all be driving available hydrogen fuel cell vehicles sooner? This is real wonky. I think I was told one time that if you were compressing hydrogen, you wouldn't be able to do it in a natural gas pipeline. It's a different compression rate. It would need to be more robust pipelines. Am I wrong? Am I outdated on my line of thinking there? Can you use existing natural gas pipelines for this? What's the story?
I saw a presentation on that yesterday, Jay.
Oh, really?
And they were talking about there has been lots of work on how to leverage natural gas pipelines for hydrogen. And I think the general message is many people believe it's quite feasible. And I know there's work going on in Europe now where hydrogen's actually being injected into natural gas pipeline, and the people are continuously increase that number. It kind of comes back to the issue we were talking about earlier, that Europe has a much bigger challenge, especially in Germany, with what to do with excess renewables. But I think once the grid becomes 16 or 17% renewable, management of the network becomes quite challenging. As you know, the cost of electricity sometimes goes negative in Europe, and people have seen it as opportunity to use electrolyzers to convert that excess electricity into hydrogen.
And then finally, how do you see the relationship between hydrogen fuel cells, your field, and the folks who are promoting, say, lithium-ion and other electrochemical batteries? Is it competitive, or can we all just get along?
I don't think that's the case. I think that when you look at electric vehicles, if you're driving around a city 15 to 20 miles a day, or even 40 or 50 miles a day, battery electric vehicles make a great deal of sense. If you're in a situation, if you own a commercial fleet of trucks, we just did a deal with DHL in Germany, and the reason they're doing it, and they envision that up to 70% of their network could be fuel cell powered in the future. You don't have to take this big truck off the road and charge its batteries for an hour or so while packages aren't being delivered. The second reason is that you're doing something in 5 to 10 minutes that's taking well over an hour. 2, fuel cells have at least twice the range than battery electric vehicles in most applications. 3, the power density of fuel cells higher. So around 150 miles, you can actually package 30% more packages in a truck than you could if you were using a battery electric vehicle. And if you think about somebody like Amazon, why would you give up all that space? And finally, once you get past 10 to 15 vehicles, the cost for hydrogen infrastructure is significantly lower in cost if you have a fleet than battery electric vehicles. And if I was going to dream out 2030, when all the taxis in New York City are running on automatic guided vehicles and they're on the road 18 hours a day, do you want to pull that cab off the road to charge it, or do you want to just fill it up with a robotic fuel or pulling up to a plug power hydrogen station and be automatically back on the road? That's what I want to do.
Yeah, well, that's a great vision. Andy, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
I think it's a great transition fuel to a carbon-free society.
Crude oil.
I think it's going the way of wood.
Nuclear.
I believe it deserves another look. I've seen studies that suggest that the amount of lives that are saved by nuclear is a lot more than the perceived threat that people believe exists.
Coal.
Probably going faster to wood than oil.
Wind.
It's great in places like the Midwest, in the ocean, cost effective. I think really part of the energy solution of the future.
Solar.
Ditto for wind. I think there are places today you can purchase solar for 1.8 cents a kilowatt hour in California. Very, very competitive.
Biofuels.
I think for long distances like airplanes, biofuels are a perfect solution because of the energy density, and that's an industry that is really going to be plagued by how you meet carbon content requirements.
Hydroelectric.
can't get any greener than hydro. I mean, the one challenge with hydro, I think many people know, is that what happens when it doesn't rain. In places like Brazil, that can often become an issue. But I believe a good mix of hydro, and that is continuous in most cases, is helpful for the grid.
Geothermal.
Right places, right locations, I think geothermal makes sense.
Energy storage.
Wow. So another fascinating subject. I think when you look at short-term burst energy storage, batteries are the right solution. When you look at seasonal energy storage, best solution, it will be using electrolyzers.
Electric vehicles.
The future. There's two types. For short distances, buy a car with a battery. For long distance, buy a car with a fuel cell.
And Andy, I'm going to put you on the spot. If I get a Tesla, can I order it with no battery and then you can put a fuel cell in it for me?
At the right price.
Okay, I'll take that as a yes.
You must be making a lot more money than I thought, Jay.
No. I'm still saving my pennies. Energy efficiency.
Obviously, efficiency should remain the number one primary area to improve to meet climate change requirements of the Paris Accord. And maybe some of your listeners don't know. Do you know which country or state has the most aggressive climate change policy?
Alabama.
No, it's a great state of New York. It passed this week. New York has more aggressive goals than Paris or any other nation.
Yeah, I think I've seen that. And then finally, fusion power.
It's the ultimate. I don't know how we do it, but it is the ultimate.
All right, Andy March, President and CEO, Plug Power. Thank you so much for your time.
Thank you for having me, Jay.
That was Andy Marsh, President and CEO of Plug Power, an integrated hydrogen fuel cell company based in Albany, New York. Andy says they've now built close to 90 hydrogen infrastructures, and you may have caught that they are using a lot of hydrogen not produced from natural gas, but chlor-alkali plants. These are plastic plants where the hydrogen has been captured, liquefied, and put to good use rather than burned off. I want to thank Andy for his time, as well as Jesse Dupree and Mel Driste from the Belay Group for setting this up. You can find plenty of pictures on EnergyCast as well as on Instagram at Host Energy. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 66. Be sure to join us next week when we learn how next-gen chips are finding their way into our energy future. Until then, I'm Jay Downhauer. We'll see you next time.